Alright, this should be fun. This is all 12 2016 multiple choice items for Module 2. So all of the Module 2 multiple choice items for 2016. Okay. They give you a graph and they want to know which of these statements is true. Well, all these answer choices talk about whether or not this is a function. So something that you should be aware of is if they show you a graph, then we like to see whether or not it's a function by seeing if it passes the vertical line test. Now, if you can put a vertical line anywhere on your graph and have it only hit the graph one time, no matter where you put your vertical line, then it is a function. But as you can see, here hits it twice, twice, twice. This vertical line hits this graph twice, all over the place. So this is not a function. Now, so that means it's either, well, that means it's not B and it's not C. So I guess the question is this graph not a function because all functions have to be linear? Do all functions have to be linear? Do all functions have to be lines? No, you could have something like that pass the vertical line test. So it's looking like it's not A, so it must be D, right? Well, don't be so fast. Let's actually check if D is correct. Choice D, the relation is not a function of x because more than one value of y may correspond to the same value of x. Well, that seems like literally the official definition of a function, textbook definition, so it's D. Remember, the vertical line test, very important to remember. Number 2, what is the domain of this relation? Remember, a domain is all the x values. Again, that's one of those very simple vocabulary type things that if you don't know it, it's going to cost you some easy points. So domain and range of relations. Domain is the set of all x values. The range of a relation would be all of the y values. So remembering that this is just a list of ordered pairs, x value, comma, y value, x, comma, y, x, comma, y. So all of the x values would be 2, 5, and 14. You just go with like all those separate x values for the domain. Number 3, again, you should have read any of these problems that you want to, watch me do. Before that, you need to read it over very carefully, more than one time if necessary, and attempt it anyway. So they're describing how that there was 14,000 miles on Denny's car at the beginning of the road trip, and that the average speed was 55 miles per hour, and the number of total miles is represented by the y-axis or the y variable, and the number of hours is represented by the x variable. Well, something you might have already seen me write down in one of these videos is that rate or speed is the same as what? The keystones want you to realize that the word rate or the concept of a rate or a speed is essentially talking about slope, okay? And so basically this 55 miles per hour, which is the speed, this rate, is going to be represented in the correct graph by having a slope of 55. So essentially, I don't know if that's going to be like the deciding factor, or if that's what's going to, have you be picking the correct choice. But that is true, okay, and it's something you should know in general. Anyway, let's see here. So the fact that we are beginning at 14,000 miles, that means that at hour 0, hour 0, we should already be, okay, it's almost like having a y-intercept of 14,000. So choice A checks out. Choice C looks like it checks out, okay, for right now. Where at 0 hours, we're already having a total miles of 14,000. This one looks like it, like I definitely can't rule it out. It looks like it's probably true. But, oh, nope. So it's not going to be graph B because graph B is not showing 14,000 miles being the total number of miles at 0 hours driven. Okay? So, I guess which graph is correctly showing a slope of 55? I guess that will be it. But here's how you can look at it, right? You see how like every graph has got a pretty much a total of 4 hours? Well, let me grab my calculator. Driving 55 miles per hour for 4 hours. So every single one of those 4 hours going 55 miles, I'm essentially going to multiply 4 times 55. And basically after 4 hours of going that fast, we should have added on 220 miles to the total miles. So looking maybe at choice D, oh my goodness. After 4 hours, our total miles is 70,000. Yeah, no. Choice C, after 4 hours, we'd be up to 15,000 miles. No. Nope, 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 nope. Not as bad as D, but it's still not C. Because look, after 4 hours of going that fast, we should be here. We should be at about 14,220. So, again, in other words, choice A also represents the correct slope of 55 miles every hour. Number 4. All right, well, this is about a dude named Edwin. You know what? I know a guy named Edwin. He is a lights out cornhole player. You would not believe it. Anyway, so this Edwin character drove 261 miles from city X to city Y in 4.5 hours. This is another rate problem, like slope. Remember, rate means the same as slope, okay, as far as the keystones are concerned. So he went 261 miles in 4.5 hours. So you can get like a speed. Anyway, he continued driving at the same average speed and drove another 145 miles from city Y to city Z. What was the total amount of time? All right, so we're going X to Z. All right, so here we go. Essentially, we're going to need to figure out how long it took Edwin to drive that 145 miles. And then we're going to have to kind of like put those two amounts of hours together, from X to Y to Z. Now look, again, let's see. 261 miles in 4.5 hours. So look, a speed is like a slope, which is a fraction. And so we're going to need to figure out if he went 261 miles in 4.5 hours, we need to figure out 145 miles was how many hours. So there's plenty of different ways, or more than one way to do this, but I'm in the mood to cross multiply to solve for X. So we do 261 times X, and then we do 4.5 times 145, which I will do on my calculator, and get 652.5, I believe. And then we're going to divide both sides by 261 to get X by itself. And so divide by 261, and that gets me 2.5. So X, 2.5, that's the number of hours it took to drive that 145 miles. So look, you got to remember the overall final question, what they're asking for is like a final answer. And remember, that means we're going to have to take that 4.5 hours and now tack on this 2.5 hours for a grand spanking total of 7 hours from X to Z. Question 5. Oh boy. Having already read the question, hopefully, we're talking about X being a number of minutes and Y being a height in feet. Well, thousands of feet. Okay? And so they give us a graph that describes the, relationship between the number of minutes that have passed compared with the height of the airplane. Okay? And the question ultimately is asking, based on the graph, how long after it starts its descent will the airplane reach a height of 3,000 feet, which essentially means just 3, 18,000 feet, 17,000 feet, 16,000 feet. So remember, this is in thousands of feet. So look, here's what you can kind of do. You could look at this and kind of go, well, based on the slope, my gosh, this is like the third question in a row about rates and slope. So anyway, you can see that, well, going from here to here, it looks like we're going down 3 every 4 minutes. So it looks like and you can just kind of keep that going, like go down 3 over 4 again, and just kind of like, again, kind of figure out how many times would you keep having to do that, or, when would you ultimately get down to 3 for the Y coordinate, or, 3,000 feet. So that's one way to do it, just kind of like let that play out. Keep going down 3 over, like how many more times would we have to go down 3 from 18 until we got to 3, and then how many times would that have meant we went over 4? You can do that. But I think what I'm going to do is just use the equation of this line. All right, and I'm going to just plug it, because look, if I can figure out my B value and my M value, then I'm going to plug in for this form, this slope-intercept form. Now, hopefully it's not, hopefully you understand that the B value is my y-intercept. Let's see, is this truly my y-axis? 3, 2, 1, okay, 0, yep. So my B value is actually 24, which actually means 24,000, and my slope looks to be -3 over 4, which, ultimately really means -3,000 over 4, but, maybe I can just use 24 for my B instead of writing in 24,000, okay, which means, anyway, speaking of that, the way I'm going to use my equation is, I want to know, okay, so what would my X value be? Like, how many minutes would it take for my Y value to equal 3? So as I said, I'm going to say like -3 over 4 instead of -3,000. And I'm going to use 24 instead of 24,000. And so over here, I can just plug in 3 rather than 3,000. And now I just need to solve for X. -21 equals -3/4 X. And then if I do, let's see, to solve for X, I would now divide both sides by -3/4, which is -0.75, by the way. So -21 divided by -3/4 gets me 28 minutes. Number 6. All right, look, don't let it confuse you that they have G and M instead of having Y and X. Your M here is like X. Your G is like Y. And you should also realize that, like choice A, for example, is probably better written like that, because then it would be in mx plus b form. Okay? And that would make, see, all you really want to do in this problem is match the correct equation to the graph. Now, if you can look at this graph and go, hey, it looks like 20 is my y-intercept, and therefore my b value is 20, and you know, you could figure out your m value, but let's look down here at the choices. If your b value is 20, that disqualifies C and D. And then you look at A versus B. I mean, they have a correct B value, a correct y-intercept. So the tiebreaker is going to be, is my slope supposed to be negative 1/10 or positive 1/10? I really hope, you know, you understand that we're going down and then right for my slope. It's a downhill line, and therefore my slope should be negative 1/10. Number 7 is, my goodness, is this just straightforward? This is, wow, this is simple. They just want the y-intercept. Remember, people, the y-intercept is where the line will intercept the y-axis. So, right there. 4, 3, 2, 1, 0. Yeah, that's the y-axis. So, it's C. That was easy. Number 8. Okay, here we go. It's a scatter plot, but look, scatter plot, schmatter plot. Like when you draw this line of best fit, all that matters is that line, the line that'll go through the scattered points. Okay, and all they want you to do is match the correct. And look again, y equals mx plus b, people. Looks like all of these choices are in y equals, so all you got to do is figure out, okay, my line of best fit, what would the correct m value be, my slope, and what would the correct b value be for my y-intercept. And looking at the choices, it looks like the only two choices for slope are 0.37 or 0.37 over 1, or 2.7 over 1. And the only two options for my b values are either negative 4 or, you know, 0. Right? Well, I have pre-prepared a line that has a slope of 2.7 over 1, and this has a prepared slope of 0.30. Yep, it's not going to be that. I mean, look at this again. You think the line of best fit through the points would have a slope of 0.37? Nope. So it's not A or B. And so now you have to figure out, well, that would have a, look, I'm going to put it right there because that would make a y-intercept b value of 0. That looks pretty good, but let's just double check. What about a b value of negative 4? That's like about 1, 2, 3, 4. Okay, so that's approximately what? Yeah, no. It's definitely going to be D, because it's got, basically, again, long story short, because option D has the correct slope of 2.7 and the correct y-intercept of 0. Number 6. Hopefully, having read this already, all this is really saying is that the range of this list of goat weights, the range is 180. Do you remember what the range means in this sort of situation? again, people, don't forget that sometimes the word range is sort of like connected with the whole domain and range, and where the word range in that context means like all of the y values. But in this context, the word range means the difference between the smallest number in the data set and the largest number in the data set. So I guess the difference between the heaviest goat and the least heaviest goat is 180. So in multiple choice questions like this, you're going to literally go through all of the choices and figure out which one. You have to go through them all, okay? And kind of just check each answer. So option A, the heaviest goat on the farm weighs 180 pounds. Not necessarily. So option B, exactly 50% of the goats on the farm weigh less than 90 pounds. Well, I mean, if 90 pounds is the median, which we cannot even begin to assume that 90 pounds is the median, so it's definitely not necessarily B. C, exactly 50% of the goats on the farm weigh within 180 I don't know, not necessarily. So D, there's a goat on the farm that weighs 180 pounds more than another goat on the farm. Well, ding, 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 ding. That's literally what the word range means. Okay, number 10. A lot here. There's a lot here. What they're asking, it's a heavy, complicated question that you should know what I'm talking about because you should have already read this. So here we go. They give you a circle graph and a list of total number of cookies of last week up top. And what they're asking is how many more chocolate chip cookies than oatmeal cookies will most likely be sold during one day next week. Okay, so how many more cookies? So hopefully you've already thought about this and tried to come up with a plan. So here's what we got to do, all right, if you're stumped. First thing we have to do is figure out like a typical number of cookies sold in one day. So what that means is that we're going to have to take all of these numbers up here and find the mean or the average. So the mean or the average we're going to have to add up all those numbers and divide by how many numbers there are. So that means we do 264, I got a calculator, plus 203, plus 318, plus 502, plus 341, plus 173, plus 299, and that gets an even 2100. And then to finish calculating the mean or the average, how many numbers were there? 7. So divided by 7. And so 300. 300 is a typical total amount of cookies sold in one day. One day. And so now we got to do how many more chocolate chip cookies? Okay, so how many cookies for each day would be chocolate chip? Well, apparently 40%. So how do we calculate 40%? How do we do that? 40% of 300. That means we're going to do 300 times 0.40. So we change the percent to a decimal, which means 0.40, and that's going to be 120 cookies are chocolate chip. And then we're also going to have to do, we also need the number of oatmeal. So we're going to do 300 times 0.15. 300 times 0.15 and get 45. So now we can figure out how many more chocolate chip than 45. So the final step is to just literally subtract 120 minus 45 and get 75. There you go. Number 11. Okay. Hopefully you've already read this through if you're needing to watch me do it. And so we talk about having 6 friends where the mean would have been 9, the median 8, and the range 16. And so the 3 friends of Carrie who watched the most movies were 18, 15, and 12. 12, 15, 18. And we want to know what numbers go here so that the mean would be 9, the median would be 8, and the range would be 16. Well, you know what? Let's start with the range. For the range to be 16, wouldn't this number need to be 2? It's not A. It's not. It doesn't go 1, 4, 4, because that doesn't make sense for the range being 16. How about the median? The median being 8. Well, for the median to be 8, because that's where the median would go. The median would go between the 12 and whatever this is. So what would this have to be so that in between these two numbers would be 8? Wouldn't that need to be 4? So that now DQs option B. And so, all right, so apparently option C and option D, that satisfies the median and the range, but which one of these satisfies the mean or the average being 9? Well, it turns out that it's going to be C. If you were to check out D, which you should, you'd get the wrong average. But if you do 2 plus 3 plus 4 plus 12 plus 15 plus 18, you should get 54, and then you would divide by 6, and you would get, so it checks out there, there, and there. So the answer is C. You just check each answer, right? All right, number 12. Number 12 talks about probability. Again, pause the video, read this thoroughly before watching me do it, okay? And hear me, listen to me do it. All right, so now that you've done that, this question is not only about probability. This question is about compound probability, because we're doing 3 events in a row. And that's why you see all these choices having 3 fractions all being multiplied together, because that's what you should do. We have 20 brown shirts, this many grays, this many blues, this many white shirts. And we're trying to figure out what the probability is of picking out a shirt and having it be brown. And so that first pick, because probability is the number of favorable outcomes out of the total number of outcomes. So there's 20 brown shirts in the box out of 60 total. So the probability of me getting that first brown shirt is 20 out of 60. But then you got to pick another brown shirt. And here's the thing. A key thing in this problem is we're not putting that brown shirt, that first brown shirt, we're not putting it back in the box. There's no replacement, okay? So that means, what is the probability of getting the second brown shirt? Well, how many brown shirts are there in the box? Yeah, there's only 19 left. And how many total shirts are left in the box? 59. Well, guess what? There's a third event for like a third probability where now the probability of getting another brown shirt is, well, now there'll only be 18 shirts left and only 58 total shirts. So again, compound probability, when you're doing more than one thing in a row and you want the overall probability, you multiply all the individual fractions, all the individual probabilities together. And so the answer should be B. They don't even make you multiply all the fractions together. 20 to 60, 19 to 59, yep, and it's B.